This is organic reactions. All those questions are based on these organic reactions. So the reactions that you normally do, you guys, it's basically this one. Okay, you do substitution, addition, elimination, and esterification. You do the first four. Normal. Others they might do. So you're doing the one in the yellow box. There is no extra. There's only 4 reactions. Remember with addition, the reason why the reaction looks like there are many, it's because when you do addition, it can be addition of hydrogen, then you call it hydrogenation. Elimination, when you eliminate hydrogen, you call it dehydrogenation. In addition, you can add water, you call it hydration. But when you eliminate water, you call it dehydration. Now, in addition, you can have addition of halogens. You call them halogenation. But when you eliminate them, you call them dehalogenation. In addition, you can add hydrogen, including halogens, meaning hydrohalogenations. But when you eliminate them, you just put the DE in the beginning. It will be dehydrohalogenation. Then you're thinking there are many reactions. It's only 4 reactions. Are we good?
Yes, sir.
Yeah, that's what you need to know. First, we start, remember these two. These ones. These ones are opposite of one another. It's addition and elimination. Maybe elimination, you could have called it subtraction, you know, because to add, opposite of to add is to subtract. But substitution, it's where you are swapping here. Remember, substitution, you are swapping. Puma wena ngena mina. Like how they do it in soccer. They remove one guy, they put another guy. But in addition, you just add, you just put another guy. That's it. You don't swap. In elimination, you just remove. You do the opposite of the other one. Esterification, that's where you're going to do the acid and then plus the alcohol. That's all. There's nothing more. All right, I'm just saying ahead of time. So remember, substitution, you swap. All right, there is a single swapping, there is a double swapping. Puma wena ungena mina. All right, so let's just see. Here's the substitution reaction. So what you have down here, you basically have C bonded with Z. So you got up, down, left. You got hydrogen, then you've got hydrogen, then you've got hydrogen. And then all you have to do is to remember naming also hydrogen and hydrogen. You've got hydrogen there. Now they say to you plus Cl2. Well, let's back off. Let's go back in time. Yeah. With this one here, addition, you are basically in addition, you'll be having double bonds, triple bonds. I'm going to put a slash, meaning you are breaking double bonds and breaking triple bonds in addition. You must get rid of double or triple bonds in order to add. But with elimination, you are creating double bonds or triple bonds. Are we together?
Yes, sir.
Okay. Good. It takes energy to do that. That HV tells you need energy. So they give you chlorine. Look here. There is no double bonds or triple bonds here in the next one. That chlorine, break it into two. You say chlorine, it's basically chlorine bonded with chlorine. So it's not going to be added. Those two are not going to be added. You're going to swap. What do I mean by swap? I mean, you take one chlorine, let's say it goes here by hydrogen. If it goes here by that hydrogen, it's a swapping, like in soccer, puma wena gungenelo. And then this one needs to go and replace chlorine there. That's what is happening. Do you understand what I'm saying?
Yes.
So that means in the place of hydrogen, you now have chlorine. In place of the chlorine, you have hydrogen, it becomes HCl. That's exactly what you are seeing there. I hope it's making sense now. That's substitution. All right. All right, so here we go. This is the same thing. Let's take this one, CH3. I'm going to break it down and say I've got carbon bonded with another carbon. Then I've got 1, 2, 3 hydrogens. It's hydrogen here, hydrogen there. And then I've got another hydrogen there. It's the same thing. I'm just doing it a structural formula. There you've got hydrogen there, which is exactly the same thing, hydrogen there. The reason why I'm making structural formula, I want you to be able to see the bromine. I'll write it twice. It's Br bonded with the Br. Can you see that? It's two of those. Yeah. Sometimes they don't have to look the same, but you'll be having single bond. So when you look at this hydrocarbon, there are not double or triple bonds. So which means this hydrogen can come and replace that bromine. And then the bromine itself will come and take the place of hydrogen there. That's why you now have it like that. Is it making sense to you now? So that means here you'll have a Br, and then here you'll have an H, HBr. There it is. Is it making sense?
Yes.
Okay, let me see if they've got another one which they don't look the same. No. Let's give you another one which does not look the same. Let me go back in time. Let's replace. Now, let's say you didn't have Br here. You only had HCl instead of Br. So the HCl, I'll write it twice. So it's going to be H-Cl. Can you see that? So you can't do this. This cannot be done. I cannot take hydrogen, put it there, and then this one come and replace there. It will be like there was no change. Can you see that?
Yes.
Yeah, it will be like there was no change. So this won't work because it makes no difference. So that means you have to take the HCl to come in a place of that. There must be a visible change. And then this one will now go there. So that means you now have HCl there. That side, it will be H with H. It will be H2. 2 H's. Is it making sense?
Yes, sir.
All right. So that is substitution. So let's go back and read the story about substitution. They are telling you any reaction in which one atom is replaced by the other, meaning there's a swapping. It's used to place a hydrogen onto an alkane. Okay, to produce, the product always are halocarbons, which means the one I gave you that example, you're not getting, here you're getting halocarbons. Can you see? There's halogens. This was an HCl. All right. And then let's go back here in time. And the acid of the hydrogen. So an acid, it's always H by something else which is not an H. So the one I gave with an H and H, they won't give you, you won't get H, because H and H is not a hydrogen. That one, H2, it's a gas. But I gave it for you to understand. Now here they say the acid, okay. Then they say it needs ultraviolet light to initiate the reaction. So this reaction needs some heat, some energy to start it up. So that's the first part now with substitution, with reaction. I gave you the first one.